All right, let's try some nomenclature practice. So let's take a look at some ionic compounds. So I've provided an example here for aluminum chloride. If we take a look at the next one, NiBr3, well, Br, that's bromide, and bromine can only take on a -1 charge to be bromide. Nickel is a transition element. It can take on more than one possible charge. So therefore, I must provide Roman numerals to identify the charge on the nickel. So this would be nickel 3, because I need 3 positive charges to balance out my bromide. So this is nickel 3 bromide. Let's take a look at the next one. So you should recognize the polyatomic ion that's in brackets. That is the nitrate anion, and it has a -1 charge. I have 4 of them. Therefore, my manganese must have a +4 charge in order to balance out all 4 of those nitrates. So this would be manganese 4 nitrate. So again, you have to memorize the polyatomic ion nitrate. The next one is has carbonate as the polyatomic ion. So again, you have to be able to recognize CO3 as the carbonate ion. And the carbonate ion has a charge of 2-. And sodium is an alkali metal. It can only adopt 1 charge. So we do not have to use a Roman numeral. So this is simply sodium carbonate. So sodium carbonate for that one. The next one, you can see that fluorine is the anion, making it fluoride. Fluoride can only adopt a -1 charge, whereas chromium is a transition metal, which can adopt more than 1 oxidation number. So therefore, I need a charge of +6 on my chromium to balance out the 6 fluoride. So this must be chromium. So chromium 6 fluoride. So that's Fluoride. All right, chromium 6 fluoride. The next one has barium as the cation, and sulfate as the polyatomic ion. So again, that's another polyatomic ion you must memorize, SO4, which has a 2- charge. Barium is an alkaline earth. It can only take on a +2 charge. So therefore, this must be barium sulfate. The next one, again, I see another alkali metal. Lithium is an alkali metal, which can only take on 1 possible charge, which is a +1 charge. And then nitrogen, its preferred charge is -3, which is a nitride. So this is lithium nitride. There we go. The next one is contains potassium, which is an alkali metal. Again, only can have a +1 charge. And then this is a big polyatomic ion here. So MnO4, that is the permanganate polyatomic ion. So again, since the potassium can only take on 1 possible charge, the +1 charge, I don't have to use a Roman numeral. And this is potassium permanganate. So permanganate. There we go, potassium permanganate. The next one, we have iron. Iron can take on 2 possible oxidation states. It can take on iron +2 and iron +3, so iron 2 or iron 3. And this polyatomic ion here, so HCO3, that's the bicarbonate ion. It has a charge of -1, and there are 3 of them. So -1 times 3 gives me a total -3 negative charge. So that means I must have iron 3. I need a 3+ charge. So this is iron 3 bicarbonate. So iron 3 bicarbonate. The next one, we saw lithium in the lithium nitride. And again, lithium can only take on a +1 charge. So I guess this one is more a matter of memorizing this polyatomic ion, which is hydroxide. And hydroxide has a charge of -1. So this is lithium hydroxide. And the last one, this one's kind of an exception as far as the transition metal goes, because zinc can actually only adopt 1 possible transition state. Zinc is always zinc 2+. This polyatomic ion over here, PO4, this is the phosphate polyatomic ion. It has a charge of -3, And since there are 2 of them, that would make a total of -6. And if there's 3 zincs and it has a charge of 2 plus, 3 times positive 2 gives you +6, so that balances out. But again, since zinc can only adopt one oxidation number, we just call this zinc phosphate. We don't have to use the Roman numeral or what we call the stock naming system. So I hope this helps you a little bit in determining the name for the chemical formula for an ionic compound.